So my name is Patrick McFadin. I work for DataStax. I'm also an Apache Cassandra committer. Been working on data and databases. Been working on Spark, a few other things. Wrote a book about data infrastructure, managing cloud native data in Kubernetes. It takes a long time to say those words, but data, Kubernetes, that's all you need to know. And part of that was AI infrastructure. So if you're interested in that, I wrote it just before ChatGPT was released, so I feel like that was a legitimate contribution. I didn't fake it. So now, I don't know. All right, let's talk about this. As I said, I've been working on Apache Cassandra for about 12 years now. And so we have some exciting things we're going to do. This is our contribution to the malaise, the craziness of generative AI, and I'm going to talk about it. So I've been putting this in front of my slides for like a couple of months now, and this is just like the safe harbor statement for everyone in the community. It's okay. We were all in here. You know, we're all kind of freaking out about this because, wow, this just happened, and if I don't get on top of it, I'm behind. Yeah, you are, but so is everyone else. Like, there's 4 or 5 people in the world that get this, and they work at Google and OpenAI. So be cool. This is what you're doing right now. You're learning together with us. So I don't get everything. I don't get most of it. But I'm willing to learn, and I'm willing to talk to people because that's how we get there. In a couple years, we'll all be veterans. Remember, we'll be at the next meetup event in a couple years, and we'll be like, man, remember back in the day when we were talking about LLMs? Yeah, that was cool. All right. So I think that there's a 3-thing statement here. And I talk about vector databases and vector as a part of an enabling technology stack for you. And you know, there are many pieces to Gen AI, but for me, what I'm going to talk about is about vector and working with vector databases. And I think the 3 things you have to really keep in mind are like the simple, that private and secure, probably more than ever now. When I used to talk about privacy and data, especially in NoSQL, people laughed. Like, why? Now, because, you know, the AI is going to know lots of things about you. And that performance problem, it's always cost. Unless you're independently rich and want to buy A100s for $10,000 a pop, cost is a real problem because this is probably the most expensive workload we're now engaged in. This is a very expensive workload. This is why, like, I love it. Microsoft's like, hey, OpenAI, here's a few billion. Can we get like 1% of your company? What kind of valuation is that? It's because they got to go buy like half of the silicon on the planet, right? This is what's happening. Okay, so where are we going? And I think this is good because we're in this cutting edge crowd. Y'all are cutting edge. Like if I was giving this talk in somewhere else, I'm not going to name names, Dallas, then we would have a completely different conversation. But you all got it. I don't need to spell LLM for you. You know how to spell it. So where are we going? What are we going to be talking about next year, 2024? Agents, yes. And in the spirit of San Francisco, this is where the gold rush is going to be, right? And agents, and Andre, I put the QR code up there, cite your sources. It's a really cool talk. You should see this talk because he just casually gets up there before like a hackathon and just is like, oh yeah, everything you're doing, just wait. And this is where it's going to be. And he's talking about agents and AGI, those 3 little letters that freak people out and get investors excited, right? Because it's going to be something that when we have that, it's going to change everything. What that is, we don't know, but it's going to happen. And what agents are these large-scale networks. They're highly connected. They're loosely coupled. I mean, that is the thing about distributed systems. My background originally was in distributed systems, but this is a dream come true. We finally like, oh, we have a use case that's really cool, besides just moving data around. But that required shared context is really the key. You know, and hello, Cassandra. This is where we've been working for a long time. And here's a funny thing. So when Cassandra started, like the Cassandra developers heard about like Gen AI and all the use cases that are exploding, there was like, oh man, it's a PDF. It doesn't have, I can't do animated GIFs, bummer. Anyway, so this is a really cool picture where they all like freak out, okay? Just imagine that. Use your own brain, not your AI. But this is just this kind of excitement within the Cassandra developer community, people building the project, like, we've been building a database for this use case for 12 years, and it's finally here. And we've been doing stuff with distributed data for a long time, but this is a use case that's really going to be cool for us, and we're excited about it. So, because we built this, and it's really cool because it's an open source project. And we built, there's lots of developers that I work with, like from Apple and Bloomberg and Netflix, that are building this every day. And it just is built for this, and we're gonna build this. This is gonna happen, this invincible brain. So when you're building your cool new startup, you need to rely on something that's just gonna be dial tone, or web tone, as Sun would say. It's going to be, I've kind of dated myself with that. But anyway, it's just this reliable thing that'll always be online that will store your knowledge. And more importantly, for your users, the people who give you money. And this is the future, right? It's this highly connected network that I mentioned before, and these autonomous agents working around the world like that. This is me asking Midjourney, give me an excited robot. He's pretty excited. But this is just because this is the way Cassandra works. Cassandra works on a global scale. You can have a cluster that spans the entire planet of Earth. We haven't tested it beyond Earth, but we're getting ready to. But we're ready. And there's also these 5 hard problems now with vector search that we're trying to solve. We talk about the scale out. This seems to be the current state of the art. Scale out is a big problem that we've been solving for quite a long time, and it's just a thing. The garbage collection problem is like with indexes, whenever you're continuously updating indexes, just kind of level setting. Vectors were, as a topic for the NLP community, were, hey, build a model in bulk, load it into some place where you can index it and then just read it. It wasn't about transactions. It wasn't about reading and writing. It was about reading. Write once, read many. And so the garbage collection problem is now becoming a problem because we're using them transactionally. And then use of disk. Again, keeping the disk space low means you're keeping your prices low. And then composability. I don't want to just do an approximate nearest neighbor search. I also want to look for keywords and things like that. If I'm going to be storing a petabyte of data and I need to search it, there are certain things that need to happen for me to make that more efficient. There is no physics in the world that says that searching a petabyte of data, all of it, is efficient. It's not. If anyone tells you it is, they're lying to you. So composability is a key part of that. And then one of the things that's really difficult because of how the vector world has started is this idea of concurrency. It's like, that was never a problem before. It was like, what? We write data into the database and we read it later, a lot. So why would we worry about concurrency? And that's the problem that we solved a long time ago with Cassandra, which we're doing now. And the library, and this is an open source library, it's pretty cool, it's called JVector. Really cool, it was the #1 repository of the day. A Java library was the #1 repository of the day for a few days on GitHub. But it's this really hyper fast indexing engine that works. And it really was born because Lucene, which does HNSW, which is embedded in a lot of vector implementations, just does not have the speed that you need. This is like Elastic uses Lucene and HNSW. We were like, this doesn't work for us. We're going to do something different. And so JVector is really the engine that powers all that. And the result has been pretty amazing. And this is like a graph of showing like concurrency. The concurrency comes up whenever you have data, when you're writing or reading your data, and then you start writing. Like as soon as you start writing, if the read speeds start dropping like a rock, there's your clue. And we built it so that if you're reading data at speed and you start writing at speed, there's no difference between the latencies. It should be the same thing. And that's pretty critical for anyone who's running an application, especially if you have users. Oops. All right, and we tested this against multiple places. It seems like everybody has this problem, and we're very happy we're solving it because this is something we solved 8 years ago, and we're going to continue to solve with vectors. And I should mention that our implementation, so I work on Cassandra, but AstraDB is our Cassandra as a service at DataStax. We make it super easy for you to use, and so you can just use a token, just like everything else, and get in there. The difference is that we're proud of what we built here, but we're also making it, remember that simplicity thing? That's the thing that we're going after. We don't want to be in the way of your building your application, A, and B, we want you to only make one choice with a database and then move on with your life and not feel any compromise. That's some psychological safety. And the price. We figured out how to do it cheaper. I'm sorry, you can't say cheap, low price. But cheap in cloud terms, what is that? Not S3 or Glacier, right? But the security is another thing. It's really interesting. The more startups I talk to, I always thought like HIPAA was like an enterprise thing, or SOX or PCI was like a total enterprise thing. Like if you work at a bank, PCI is a thing. Oh man, startups everywhere are working with financial data. They're working with medical data, and they have to have this or you can't sell anything to a customer. Regulated environments. So, hey, guess what? We have all that for you. And I just never thought I would tell a startup crowd, HIPAA. Okay, here we are. But that just shows you like, oops, this is different. We're working with personal information from the beginning. And you should respect that for your users and make it easy for yourself. So what about some of the vector use cases? And I'm going to try to like outline what I think this is going to be. It's what it is now, but also for agents in the future. LLMs. So the polls guys I talked to, Christian in the back, hi. Go say hi to them. This is the thing about LLMs, which I think is really interesting, is we are learning more about the nature of LLMs now, and that's really good, but what we're learning is that communication is really solid, right? They can, good talkers. Remember I said earlier, like when you do the ChatGPT voice thing, it'll talk your ear off. And it's good communication. It's not Siri with this stunted like, hello, here's a web search for you. No, it's having a nice conversation with you. And the reasoning part is a surprise. Like you can have it give you steps. Like, hey, how would I do this thing? And it tells you the steps to do it. And it could reason through those. That is a really critical and key part of why agents are very interesting. Because for an agent to work, it needs to be able to reason through the steps and without a human. And if LLMs weren't able to do that, we would not be in the place we are now. It would just be this really great like voice interface. But the reasoning is what really changes the game. Now, the thing that they're terrible at, and the thing that we all make jokes about, is the fact that they are just really good liars, right? They will tell you the absolute wrong thing with confidence. Like, if you say like, yeah, how do I take the bus into Oakland? It's like, well, first you get on the boat, and like, hold on. And it'll just tell you this whole thing, and that's so wrong. And if you ever want to have fun, I don't know if ChatGPT will do this now, but ask it about yourself. Like, I had it like, tell me all about Patrick McFadin. And it started out pretty good. It like had some knowledge of presentations I've given or books I've written, whatever. But then it went off the rails. It was like, at the end, I had invented air. And I think it's because it's like, it was trying to help me. It was trying to be pleasing. It's like, look, I really want to tell you. I'm like, wow, thanks to ChatGPT. Am I that bad? Do you have to make up stuff about me? But there's no facts. There's no facts. And that's a problem, especially whenever we're trying to build trust. Trust is a huge problem right now with AI. And we've given our life to AI. Look at us. But go to a random place and ask just person off the street, what do you think about AI? It's probably not a really positive experience because they're going to have this, they're going to be like, oh, well, it seems dubious. And, if they've ever used ChatGPT, they know that it lies. People talk about this all the time. Education is banning ChatGPT because they feel like that's the problem. It's not trustworthy. and kids are going to use it to cheat. But if you, I told my son, if you use this to cheat, you deserve the grade you get. Yeah, I'm telling you, because he was like, oh, it's really great. I had to tell him how to use it. Like, no, write your own stuff and have it graded. Do not have it write your stuff because it will turn in the wrong thing. So these multi-turn autonomous agents, the agent itself is just a small piece of code that makes things work. A good example of this is like AutoGPT. AutoGPT is a massive project, 150,000 GitHub stars. Really cool. And what it does is it creates a framework for an agent. But it requires an LLM to do the reasoning and to do the language portion. But the vector database is going to be that source of truth. And I don't think I need to explain this too much, but multi-mode, I mean, right now we're using text, maybe a few pictures, but multi-mode is the future. And it's just because we as humans, we interact with each other in a multimodal. Like, if we're talking and, and you tell me something and I go like this, you know what I'm telling you. That baffles a computer. Well, with multimodal, maybe not. But there's also other modes, sound, X-rays, all these different things. And there's a really cool paper, this meta transformer paper that really got into it. They got super creative on all the different modes of data that are out there. But it is showing you where research is looking forward. They're like, hey, let's look into the future. And these modes of data will need to be stored in an embedding for use inside of your application. This is the truth part of their knowledge. It's not embedded in an LLM. None of these modes will be embedded in an LLM. You're not going to embed, say, all the pictures from the National Gallery of Art in an LLM. That's not going to happen. It's going to be vectorized, it's going to be embedded, and then you can use that. So Wikipedia data changes all the time. This is a great example, actually, of Wikipedia, because Wikipedia is going more and more multimodal, but it changes all day, every day. And the one time the LLM looked at it, sure, that was good back, 2021? Or if you fine-tune your own, great. But what if you got the absolute newest data, right? And unfortunately, that's the nature of our human world, as things change quickly. And this is the problem. I've been here before, and it's going to get weirder. We're just going to use more data. And that was kind of the rallying cry behind AI for analytics, was like, well, we could do that if we had a few petabytes of data to analyze. What do you think it's going to be like in the future? No, we could do that if we have a few exabytes of data to analyze. It's only going to get worse. And if you think about like applications and how they collect data, it makes sense. It's all those multi-modes of data. I don't know, have you ever taken a video and seen how big those files can get? A 20-minute video can be 5 or 6 gigs. That's pretty big, but there's a lot of information in it. So we're going to use more data, and we better be prepared. And this is why Cassandra developers were so excited. We're like, yes, we do petabytes, no problem. But now we're actually having these conversations internally. We're like, inside the project, we're like, who's doing exabytes? It's very possible that it could be Huawei, who's a big Cassandra user. So this is a picture-worthy diagram. Yeah, I'm doing prompting on my own. Look at you, you're all great. But the reason I say this is picture-worthy is because this is the pattern that we want to talk about. It's like this thing where we have a vector DB that works with an embedding and use the LLMs. This is your RAG pattern. And everyone should know that, the retrieval augmented generation, RAG. This is what everyone's doing right now. This is going to continue to be the pattern for a long time. And agents especially, because what this is, and I'm going to zoom in here, is that embedding part is the truthiness of the data. So the LLM, when you ask an LLM, hey, what's the best way to take a bus to Oakland? The LLM will say, okay, first of all, go to the transit center. Here's like 4 options. I don't need it to wander off. I just needed to get the truth of data. And maybe there's some real time in that. All the buses are closed. and it'll tell you. I'm going to suggest a couple other options. Maybe you should take a boat because the ferry goes from one terminal to the other, and that's only a 20-minute ride. And right now the traffic is so bad you won't get over there for 2 hours. It's going to do the reasoning, but use real data. And this pattern right here, we're excited about because in Astra, we have production customers doing it right now, and it's changing their lives. This is one of them, Priceline.com. You can go to Priceline. There they have this thing called Penny, which is a little chat thing, but it uses your data. So if you've booked something, you can ask it a question like this, like, "Hey, I love the question. Is this place I'm staying in sketchy?" But I would ask that too. But this is a real thing, and it's running at scale. And sure, it's a chat app, but just wait until Priceline and other companies start doing agents. Now I could say, "Hey, Priceline, I'm going to be in New York. Just let me know whenever there's a really cool deal on something, that I'm what I'm interested in. Tell me when there's something that I should look at." And maybe it'll come in and say, "Oh, you know what? There's this great tour that's leaving tomorrow. You should be on it. Here, I got you a ticket." That's cool. That's agents. That isn't a chat. That's an agent. So I'm just going to put up the link here. And this is because I love startups. We are doing great. We're trying to do great stuff for startups, which is the thing you need, which is free stuff. The thing you need is expertise and credits. And so we have a accelerator program, which is seeming to be really popular, which is great. That's why we created it. But when you go into Astra, use your business email address. We'll find you. There's also a chat in there. You can chat with us. And you can say, "Hey, look, I have a project. I want to join into your accelerator program, and we'll help you out." There's real engineers in our chat, by the way. They're not chat bots. They're humans. One of them's like Melissa. Melissa's awesome. But they're going to help you get there faster, because right now that's the name of the game. No one has this all figured out, and we're here to not only provide you with awesome infrastructure at a low price, and in some cases with a lot of free credits, but also with just some human help. Like, "Hey, I'm writing my app. I'm trying to do RAG. Can you give me a couple of pointers here? Oh, let's look at your use case, and we'll get on a Zoom or something like that." That's kind of what we need right now. That's very good. Nice. That's the first person that's ever noticed that. I didn't type the HTTPS. It'll just redirect. Don't worry. Why don't you try it right now? It'll redirect. Yeah, because actually that site will go to Okta. Yeah, so if you want to know the implementation. Oh, here, since we're all friends now. Yeah, so this is our authentication is run by Okta. Thanks, Okta. And then our entire infrastructure is run on Kubernetes. So now you know all the details. And that's why it works awesome. And it is HTTPS once you get there. Man, tough crowd. And that QR code will take you to that. I think that's all I have. Oh, one more thing, and Steven said I could do this. I'm one of the conference chairs for the AI Developer Conference and the Cassandra Summit, which is 2 conferences in one. San Jose Convention Center, December 12th. It'll be the last AI conference of the year. This is a Linux Foundation open Gen AI Summit. So this is for the Linux Foundation. They're the ones running it. It's not me. I'm just one of the people who get to evaluate talks. There's probably about 7 or 8 tracks of talks. And here's the most important thing. The companies that will be giving talks are people like Apple, Uber, Netflix, Bloomberg. They do not do AI events, really. This is the only one they're doing. And because it's a Linux Foundation event, right? It's an open data event. So if you want to come see all these heavyweights have been doing this stuff for a while, this is a great opportunity. And use this code down here, get 20% off, and do it before the end of November, and you get like the early bird discount. It's super cheap, and it's in San Jose. It's a Caltrain away. And if you want to connect with me on LinkedIn, you can connect with me there. I love connecting with everybody. And, I'm really here to help. I have 17 seconds. Oh, I'm over 18 seconds. So, okay. All right. That's all I had. I'm just going to leave that up. Be happy to connect with anybody after this. Thank you.
Yeah.